Hello class, today we are going over section 8.2, which is using the distributive property, and we are going to be using this to factor. By the end of today's lesson, you'll be able to factor using the distributive property, factor by grouping, and also begin to solve some equations after we have factored them. The idea of factoring using the distributive property is actually undoing the distributive property. So like I said in the last video, the GCF is going to be a huge factor for us throughout this entire chapter. So what we need to do is we need to find the GCF of these three terms. So first we're going to look at the numbers, which are 15, 20, and 35. So we're looking to see what those numbers have in common. When we're looking at 15, 20, and 35, they all have a 5 in common. Then we're going to go through and we're going to look to see if they have any variables in common. The first term has an h, the second two do not. So h is not part of our greatest common factor. The first term has two m's, the second one only has one, and the third one has 1. So I can take a single m out of all three of those terms. The middle term has an n, but the first term does not. So I can't take an n out either. So our greatest common factor is 5m. Then what I need to do is undo the distributive property. So our 5m is what we have pulled to the outside. And now I need to look at each term separately. So what I'm going to go ahead and do is take this first term and say 15 divided by 5, which gives me an answer of 3. Then I'm going to look at my variables. I'm saying I took an m outside the parentheses, which means I'm going to have one m left in here instead of 2, and an h. So left over from that first term, I have 3, h, and m. If I want to double check my work, I could pretend like I'm distributing. 5 times 3 is 15, m times m is m squared, so I have 15hm squared, which is what I started with. Then I'm going to look at the next term. I'm going to do the same thing, starting with dividing the two numbers. So 20 divided by 5 gives me an answer of 4. Then I have mn to start. I took the m to the outside, so the only thing that's left is the n. Again, double checking, 5 times 4 is 20, m times n gives me mn. So I'm back to that starting term. The last piece that I have, dividing the two numbers, negative 35 divided by 5 gives me a negative 7. I had one m, but I took one m out, so there is nothing left over. Double checking, 5 times negative 7 is negative 35 with an m on the end. So what I've done here is I've taken the greatest common factor to the outside, and everything that is left over when I pull out that GCF is on the inside. So my factored form is 5m parentheses 3hm plus 4n minus 7. Trying another one. So we're looking at negative 4a to the second b minus 8ab to the second plus 2ab. Again, I want to start with my numbers and see what the biggest number I can divide all of them by. If I'm looking at negative 4, negative 8, and 2, the biggest number I can divide by is 2. We always want to make sure that the GCF that we're pulling out is a positive number. So even though I've got a negative on the 4 and a negative on the 8, there's not a negative on the 2, so I can't pull that negative number out. Then I'm going to go ahead and look at the variables. 2 a's, 1 a, and 1 a, so the most a's I can pull out is 1. 1b, 2b, and 1b means that the biggest number the biggest letter I can pull out is just a single b. So now I want to go through again and double check this factoring. Dividing the numbers. Negative 4 divided by 2 gives me negative 2. I had 2 a's, I took one out, which means I have an a left. I had a b, I took it out, so I have no b's left in that first term. Moving to the second term, negative 8 divided by 2 gives me a negative 4. I had an a, I pulled out an a, so I don't have any a's left. I had 2 b's, I pulled out a single b, so I have 1b left. With the last term, dividing my numbers, I have positive 2 divided by 2, which is positive 1. I had an A, I pulled out an A. I had a B, I pulled out a B. So I just have 1 left for that last term. Again, you can double check your work. 2 times negative 2 is negative 4. A squared, B, negative 8, A, B squared, 2A, B, which gets us right back to this starting expression. Go ahead and try this one on your own. Looking at what we have here, 9 is our greatest common factor. We can pull out a y from each one as well. So I've got 9y on the outside. When I divide, 27 divided by 9 is 3. Had 2 y's, took a y out. So there's a y left over on the inside. 18 divided by 9 is 2. Had a y, took the y out, so there's nothing left on the inside other than the 2. Factor by grouping is similar to the distributive property factoring, but it works when there are 4 or more terms. The key thing is that you have to be able to pair up the terms, so 4 terms, 6 terms, 8 terms, anything like that. The terms need to be able to be grouped by a GCF, and the remaining factors either need to match exactly or be opposites, so carefully dealing with the negatives. We'll get to an example of that in a minute. So in this situation, I have 4 terms, 1, 2, 3, and 4. In order to factor by grouping, we need to split them into 2 pairs. So we're looking at 2 separate distributive property factorings. For the first one, I've got 4QR and 8R. So in terms of the numbers, I can pull out a 4. 4 is the biggest number I can divide both by. And looking at the letters, I can pull out an R. So when I'm looking at that, I have 4 divided by 4, which is 1. I have a Q left over, and I took the R to the outside. Looking at the second term, 8 divided by 4 is 2. I had an R, and I pulled it to the outside. So left over in that parentheses is 1Q plus 2. Then I'm going to move on to my second pair. I've got 3Q and 6. The biggest number I can pull out is 3, and I can't pull out a variable because the second term doesn't have a variable. So when I have 3 divided by 3, I've got 1, and that Q is left over. 6 divided by 3 is 2. So now what we need to observe is that these 2 pairs of parentheses are exactly the same. That is the first part of our answer. So 1Q plus 2 is the first part of our answer. The parentheses is only listed once. Each factor has the same parentheses. Our leftover factors, so what we pulled to the outside, become our second pair of parentheses. So I took out a 4R and I took out a 3. Now, looking at if this is a positive or a negative 3, I pulled out a positive 3, so we are going to be adding 3 onto the end. So our first term in these paired parentheses for the factors come from the matching parentheses pieces, 1Q plus 2 and 1Q plus 2. The second parentheses come from the leftovers, come from what we pulled out, the 2 GCFs. So 4R plus 3. Doing another example of this, we're going to split it down the middle. And first, I am looking at the first 2. So I've got 2CD minus C. The only thing that they have in common is the letter C. So I'm not pulling out any numbers, so I still have 2. I took out the C, and I have a D. Then I'm going to subtract. I had the C. I took it to the outside. So when you have something and there is nothing left over, we're going to put the 1 there as the placeholder. So that 1 is a placeholder if you've taken everything else out. Now, we're looking at negative 8 and 4. So I'm going to pull out a 4, and I'm going to have negative 2D. Negative 8 divided by 4 is negative 2, and 4 divided by 4 is 1. Now, looking at these 2 pairs of parentheses, I have 2D minus 1 and negative 2D plus 1. Same terms, but with opposite signs. 2D is positive, 2D is negative. 1 is negative, 1 is positive. So what I can do to fix this problem is instead of pulling out a positive 4, I'm going to pull out a negative 4. If I do negative 8 divided by negative 4, I end up with a positive 2D. If I do positive 4 divided by negative 4, I'm going to end up with a negative 1. So now my two pieces inside of the parentheses match exactly, just like we want them to. So my matching pair is 2D minus 1. The second parentheses comes from our GCFs, so C minus minus 4, because we pulled out that negative 4. Go ahead and try this one on your own. Notice from the first two terms we can pull out an n. Both of them have an n. So we're left with r plus 5. In the second one, we have negative r and negative 5. I can pull out a negative from both of those and be left with r and 5. So our matching term is r plus 5. Our GCF term is n minus 1. Notice how in this problem I put the GCF term first and the matching pair second. It does not matter the order that you put your parentheses in. The GCFs can come first or they can come second. The matching can come first or the matching can come second, as long as it is only listed once. So the last part of the lesson involves factoring and solving. In order to solve this type of problem, we need to have it set equal to 0. So if I'm looking at c squared is equal to 3c, right now neither side is equal to 0. We always want to keep the c squared positive, or any exponent with, any variable with an exponent needs to stay positive. So I'm going to move this 3c to the other side of the equation by subtracting. So I have c squared minus 3c is equal to 0. Now I need to do the factor part. So when I'm looking at c squared and negative 3c, they both have a c in common. So if I take a c to the outside, c squared is left with just c. Negative 3c is left with just negative 3. And that's still equal to 0. In order to find the final solutions to the problem, we need to set each piece or each part of this equation equal to 0. So the first part is the GCF. That's equal to 0. This is a solution. Then we do our second part. C minus 3 is equal to 0. This one actually requires me to finish solving a problem by adding 3 to both sides. And I get C is equal to 3. Now, we can go back and check both of these solutions in the original equation. 0 to the second power is 0, equals 3 times 0, which is 0. 0 equals 0 is a true statement, so that solution works. Checking the second one. 3 to the second power is 9. 3 times 3 is 9. 9 is equal to 9 is again a true statement. So these are the two answers that make this top statement true. Go ahead and factor this one to find the solutions on your own. It's already set equal to 0, so all you need to do is pull that n out from both terms. You get n and then in parentheses n plus 14. That is equal to 0. Setting the first part equal to 0, you get n is equal to 0. Solving for the second part, you get n is equal to negative 14. If you have questions about this or any other part of the lesson, please let me know when you get to class.